Hello, welcome to part 6 of our Windows Server 2012 course. For today, our topic will cover iSCSI High Availability Block Storage. So, what is it? The block storage. In virtualized environment building, a host cluster with Windows 2012 can limit downtime due to hardware failure. However, this scenario does not help if you need to take down the VM for a maintenance. If the downtime for any kind is not an option, creating a VM guest cluster on top of your host cluster became more relevant, which is in 2012 improvement. The guest cluster can service the workload by taking one virtual machine node down for maintenance, while the other will serve and still running. In addition to the shared block storage is directly presented to the virtual machine by utilizing iSCSI software initiator. Guest clustering run inside Hyper-V guest computer, and it supports high availability for workload within the VM. If you add guest clustering to the previous scenario, you can manage cluster within the VM. And it is cluster aware applications and services by moving the apps between virtual machine within the cluster without a downtime. So what do we need? A requirement enabling iSCSI software. We need target block storage, leveraging the existing Ethernet network. No additional hardware is required, and with HA server you will share the storage, and either with fiber channel or serial attached SCSI or SAS array. If you enable guest clustering, you need to provide block storage for any running Windows server. So, technical review for the iSCSI software. Microsoft iSCSI software target is a feature under the file server role in 2012. It can be full compliance with iSCSI protocol and as outlined in RFC 3720. MS iSCSI Initiator provide a way to enable an iSCSI for VMs so that they can connect to the target servers, and in a heterogeneous environment with other operating systems. MS iSCSI software target can also provide storage access such as Linux or Mac. With iSCSI Initiator software, it can also be used for clustering configuration, and the changes improve scalability. Also, it help around supporting the HA, and the support for this goal to provide continuous availability to support workload within less than 60 seconds of downtime. Next is the multi-terabyte volumes. So what they are: multi-terabyte volumes in 2012 and Windows 8. It helped to enable enterprise customers to deploy multi-terabyte and NTFS volumes, and supporting consolidation scenarios for maximum storage utilization. Historically, customers have not deployed large NTFS volumes, and the average deployment size were approximately around 500 GB, because in the event of system corruption, the entire volume will be basically not usable, and that will impact the service. Running check disk in 2012 and Windows 8 help around availability for error corruption detection, and it help around while the remaining online with data availability. The corruption related downtime is proportional to only the number of corruption on the volume. In 2012, active monitors the health state of the file system volume and provide health state to the admin, and admin can choose to see any downtime for transit or corruption events. Improve NTFS availability within online scanning and repairing. In 2012, NTFS has been enhanced to maintain integrity, data integrity, and cost-effective around online corruption scanning, online repairing capability. Also, there are two key enhancements which made into NTFS within 2012. These two keys around first one target that need to maintain data integrity on inexpensive, commodity storage, and this can be accomplished by enhancing NTFS rely on the flush, and you can see the command about the flush requirement for the handshake. Also, this means that you can safely use cost-effective industry standard SATA drive. So what do I need as a technical review? In the event of file system corruption, which what we've seen with the previous Windows servers, file system volumes will taken offline and data will be unavailable until you do the repair or you bring it back. The time for the check this complete, again similar to the previous scenario, will be proportional to the number of files and volumes and the size. And Windows 2012 address all these problems by prioritizing the file availability when corruption occurred, and it's leveraging a new module for the system corruption. This module includes improving self-healing NTFS and self-heal more issue online without requiring check disk, and would impact basically the time is taken to complete this process. Also, you will have an online analysis, which in the previous module almost all of the offline time required to run the check disk, and that take time and depend on the size of the disk. In 2012, the analysis phase of the check disk, which was responsible for the majority of the offline, became an online background task. So it's running, utilizing less time and improving the process of accomplishing or fixing the corruption within the file system. Because of the analysis, phase has already completed, no additional scanning is required or detection, and check this directly fix the identified issues. Technical overview for the check disk in 2012. This is how it looked like, and you can see the files, size of the files from 100 million to 300 millions, and the times taken less than basically 8 seconds to the arrange or fixing the event, because it's always running in the event of corruption. Next, we have the rapid and efficient data movement utilizing intelligent storage array. So what is it? Intelligent storage array will basically maximize investment in intelligent storage by making easier data move, shifting between sort of the storage devices. It will help us to offload data transfer and enable the admin to rapidly migrate VMs. Also, by offloading file transfer, the storage array ODX minimize latency and improve the utilization for the CPU network consumption. In 2012, offload file transfer is transparent and automatically happening when moving data and copying files by drag and drop or shifting it with Windows Explorer or utilizing the command line. So what do I need? ODX, as a technical overview, uses token-based mechanism to read and write between the intelligent arrays, and instead of routing the data through the host, small token is copied between the source server and the target, and tokens as point in time representing data. An example, when you copy a file or you migrate a virtual machine between storage location within the storage array. A token represents a VM file is copied and moving the copy to the underlying data through the servers. A very high level how that will look like, the steps as we described earlier, involving token-based copy between the VMs, and you can see the underlayer around the intelligent storage array, shifting and copying data across the journey from the source to the target. Token-based copy. First, the journey is as this 5 steps. A user copy or move file by utilizing Windows Explorer or through the command line. Windows Server 2012 basically automatically translate this into a request and supporting the array. A token getting issued for copying the data between the source and target, and the token is delivered to the storage array. And the last step will be storage array internally perform the copy and provide status information to the user. That's all what we have for today. I hope you learned something useful, and I shall see you next on part number 7. Thank you for listening.